Can a simple terminal block, normally used only for wiring, be turned into a working TV antenna? Today, I'm putting that idea to the test. First, I measure the length of the 8 sections of the electrical terminal block against a metal clothes hanger, then use a marker to mark the cutting points. Measuring and marking beforehand ensures that all the metal pieces are cut to the same length, making the assembly more accurate. Next, I use cutting pliers to cut along the marked lines. After cutting, I end up with several metal pieces of identical length. These pieces will serve as the antenna's receiving elements. Then, I take another metal clothes hanger and mark 4 cutting points on it. After that, I use the pliers to cut at each marked location. Once finished, I obtain 2 elongated U-shaped metal pieces. These will act as the supporting frame and connecting structure for the receiving elements, giving the antenna a stronger and more balanced design. Next, I insert each metal rod into the terminals of the electrical terminal block. Then, I use a screwdriver to tighten the screws and secure each rod firmly in place. This method provides a strong mechanical and electrical connection without the need for soldering, while also making future adjustments much easier. I continue installing the remaining metal rods in the same way. Each rod is spaced 1 terminal apart, creating even spacing between the receiving elements. This spacing helps reduce interference between the elements and improves the antenna's signal reception. Don't forget to subscribe to support the channel and turn on the notification bell so you never miss my latest videos. Once completed, all 6 metal rods are securely mounted on the terminal block, forming the main receiving structure of the antenna. Next, I attach the 2 legs of 1 U-shaped metal piece to the 2 center terminals of the terminal block. Then I install the second U-shaped piece on the opposite side. These U-shaped pieces connect the receiving elements together while adding strength and balance to the overall antenna frame. In the next step, I wrap copper wire around the metal rods. The copper wire creates an electrical connection between the receiving elements, allowing the received signals to flow evenly throughout the antenna. It also increases the effective conductive path, helping improve overall signal reception. Let me know where you are watching this video from. Don't forget to comment the country you are currently living in down below. I'm really curious to see which parts of the world my videos are being watched from. I repeat the same process on the opposite side, ensuring both sides of the antenna remain symmetrical for stable performance. Next, I'll connect the wiring for the antenna. First, I strip the ends of the electrical wires to expose the copper conductors, then twist the copper strands together. This prevents the strands from fraying and creates neat, secure connection points. Next, I twist one wire around the metal rod mounted on the electrical terminal block. This connection carries the received signal from the antenna's receiving element into the wiring system. I repeat the same process with the second blue wire, attaching it to the metal rod on the opposite side of the terminal block to create two balanced signal paths. After that, I strip the remaining ends of the two electrical wires and twist the exposed copper strands, preparing them for the next connection step. Next, I use a long coaxial cable as the connection between the antenna and the TV. First, I strip the insulation from one end of the coaxial cable to expose the inner conductor. This prepares the cable for the connection while ensuring stable signal transmission with minimal signal loss. Then, I connect the two conductors of the coaxial cable to the two antenna wires, creating the signal path from the receiving elements to the TV. Next, I wrap electrical tape around each connection to secure the joints and protect the contact points from becoming loose during use. Finally, I wrap another layer of electrical tape around both wires together, keeping the cable neat, reducing tangling, and improving durability during everyday use. For the other end of the cable, I repeat the same process to create another connection point. Next, I attach a TV coaxial connector to the cable. This connector allows the cable to plug directly into the TV's antenna input, making installation quick and convenient. Then, I wrap electrical tape around the connection to secure it firmly. At this point, the antenna assembly is complete. Next, I'll build the support stand to keep the antenna stable during use. First, I use a wooden dowel as the support pole and drill a hole through its center. This hole will be used to securely mount the antenna assembly. Next, I prepare a wooden board to serve as the base. I apply hot glue and attach the wooden dowel firmly to the board. This base keeps the antenna upright and provides better stability during operation. Then, I position the electrical terminal block on top of the wooden dowel and use a screw through the drilled hole to fasten it securely. With that, the homemade antenna made from an old Wi-Fi modem is finally complete. Now, I'm going to test it in real-world conditions to see how effective it really is. First, I'll switch to a TV channel to check the signal reception without connecting the antenna. As you can see, without the antenna connected, the TV only displays the message, no signal. Next, I'll connect the DIY antenna to the signal input on the back of the TV for the actual test. And here is the result. Almost immediately after connecting the antenna, the TV channels begin to appear. The picture is clear, the colors remain stable, and there are no continuous signal interruptions. To make the test more convincing, I'll perform one more experiment. I disconnect the antenna from the TV and observe as signal changes. As soon as the antenna is unplugged, the screen instantly returns to the no signal message. All channels disappear, confirming that the signal truly came from this homemade antenna. Now, I'll reconnect the antenna once again. As you can see, within just a few seconds, the channels reappear and continue working normally. This proves that many electronic parts that seem to have only one purpose can be reused in completely different and surprisingly useful ways. Not only does this save money, but it also opens the door to many more exciting DIY ideas. If you enjoyed this project or found it helpful, don't forget to leave a like and subscribe to the channel. Your support motivates me to continue creating more repair, recycling, and DIY projects in the future. Thank you for watching, and I'll see you again in the next video.